Hello there. We're looking at equations of tangents to circles. So make sure that you're familiar with the equations of circles and how to manipulate equations of circles to find centres, etc. You also need to be familiar with locating the midpoint of a line, because as you can see on this example, I've given you the centre of the circle and a point that we're trying to find the tangent to, but you might be required to, if you've got 2 points that form the diameter of the circle, to find the midpoint. Not a huge ask, but just make sure that you are familiar with those before you crack on with this video. So assuming you're okay with those, let's have a look at how we do it. So first of all, if we're going to find the equation of this tangent, the tangent is a line that just touches this point on the circle and represents the gradient at that point. So if we're going to find the gradient of this line, we need to find the gradient of the radius first. And the property about the radius and the tangent of a circle is that they meet at right angles. So because they meet at right angles, we can find the perpendicular gradient. So without further ado, let's get started. So the gradient of a line between 2 points, you do the change in the y coordinate divided by the change in the x coordinate. Change in y over change in x, or rise over run as some people refer to it. So I'm going to take this point down here as my second coordinate and this one as my first. So my second y coordinate is -1 and my first y coordinate is 3. And my second x coordinate is 4 and my first one is 2. And if I work that out, I end up with -4 over 2. My gradient is -2. So that means that I now have the gradient of my radius. In order to find the perpendicular gradient, the gradient of my tangent, I'll need to do the negative reciprocal. So you make it positive and then you do 1 over. So if you make it positive, it's 2, and if you do 1 over, you end up with the gradient of the tangent is 1/2. A good way to check is that if you've got two perpendicular gradients, m1 and m2, they should multiply together to give -1. So in this case, -2 times 1/2 is indeed -1. So now that we've got a point where we're going to find a tangent and a gradient of our tangent line, we can apply a bit of core 1 coordinate geometry and find the equation. So the way I'm going to do it is by doing y, take away the y coordinate of the point we're looking at, and then do the gradient times x minus the x coordinate of the point we're trying to find the tangent to. So we end up with y minus -1, and then the gradient is 1/2, and you x minus the x coordinate. And if we tidy all that up, careful of your negatives, we've got x over 2, or 1/2 x, or 0.5x. It's all the same. And then 1/2 of 4, which is 2. So finally our equation is 1/2 x minus 3. And that's the equation of the blue dotted line. And that will enable us to find out, for example, where does the tangent cross the x-axis or the y-axis. And we can apply those kind of problems. There you go, just so it makes sense at the end there. Our blue line is that. And that's how you find the equation of a tangent to a circle.